Now there are total 6 steps involved in a hypothesis testing. These 6 steps are common irrespective of any type of the test. Now we are starting with the first test. So as you can see on the screen, at the top I have displayed the steps that are involved in the testing and highlighted step 3 as we will only see this step in detail because rest of the steps are common for all the tests. Then on the right hand side, I will be displaying tests from each of the category that we saw earlier. So first category here is when the sample size is greater than 30. We have 4 tests here: single mean, single proportion, difference of mean, then difference of proportion. So we'll start with the first test, that is for single mean. This test is to check if the hypothesized population mean is equal to sample mean. Or in other words, it is to check if our sample shows enough evidence so that we fail to reject the null hypothesis that makes a claim about the population mean. Now since the sample size is greater than 30, we can use Z statistic shown here. Once we calculate the Z statistic, we can move ahead with the remaining steps shown at the top here. So that is a single mean hypothesis test for sample size greater than 30. Now let's move on to the next test, which is for the single proportion. Recall that a population proportion is a fraction of the population that has a certain characteristic. Similar to testing for mean, here we will check if the hypothesized population proportion is equal to sample proportion. Or in other words, it is to check if our sample shows enough evidence so that we fail to reject the null hypothesis that makes a claim about the population proportion. Again, we will calculate the Z statistic as shown here. So we have P hat, which is sample proportion. Then we have P naught as hypothesized value of population proportion, that which we are testing. And N is the number of trials. So again, after calculating the test statistic, we can move ahead with the next steps as shown at the top. Then our next test is to test the difference of mean. So a difference of mean test is used to compare two populations and to know if the difference is significant or not. Now there are two assumptions associated with it. Assumption number 1, samples are independent. And assumption number 2, that population is normal or n is greater than 30. If n is less than 30, then we follow a different procedure, which we will discuss when we discuss a second category of test. So for now, we are considering the second assumption that population is either normal or n is greater than 30. Now let's take an example of this to understand it better. Let's say a company identified a skill gap among its employees and designed a training program for its 50,000 employees. They ran a pilot and took a sample of 100 employees and then made them go through the module. They took their pre-module score and post-module score and found that the mean has improved. Now we will test this hypothesis that the training program is effective using the difference of mean. So first we will formulate our null and alternate hypothesis using a difference of mean as shown here. The null hypothesis is mu1 minus mu2 is equal to 0 and mu1 minus mu2 is not equal to 0 or greater than or less than 0 is our alternate hypothesis. Then the formula to calculate the Z statistic is given here. So we can calculate the Z statistic and then we can proceed as per the steps given at the top. So that is how we test for the difference of mean. Now the last test in this category is for the difference of proportion. Again, similar to difference of mean test, we use this test to determine whether the difference of mean between two proportions is significant or not. Let's take an example for this as well to understand it better. So a company launches a drug and claims that this is equally good for both men and women against cold. They then took a sample of 200 women and 400 men volunteers and found that 42% women caught cold and 53% men caught cold. Now we will check if we can reject the company's claim. So our null hypothesis would be that difference of proportion is 0 and the alternate hypothesis would be that it is not equal to 0. Then the formula for calculating Z statistic is shown here. Now this is a complicated formula, so you don't have to remember this formula at all. In fact, you don't have to remember most of the steps that we are discussing here. It will all be done in the software, but you must know what is happening in the background and have some idea of the concepts. That is the whole purpose of explaining these steps. So again, we will calculate the Z statistics from this formula, and then we can proceed with the steps shown at the top. So that is how we test for the difference of proportions.